Topics in post-harvest technology. Chilling injury of horticultural commodities. Cause and effects. What is chilling injury? Chilling injury is physiological injury that occurs to plant tissues due to their exposure to temperatures above their freezing point, but below 59 degrees Fahrenheit. When chilling sensitive plants are exposed to a chilling temperature, they experience a change in their cellular membranes, either broadly or locally, from a liquid crystalline to a gel state, and this results in metabolic dysfunction, which is known as chilling stress. Chilling stress leads to an increase in membrane permeability, an alteration of cellular structure, and interference in cellular energy production, especially ATP production. Chilling stress also causes an increase in respiration rate, a reduction in photosynthesis, and a slowing of protoplasmic streaming. It also stimulates the production of ethylene, and there are many other effects. Many plants of tropical and subtropical origin are chilling sensitive. However, some temperate crops, such as asparagus, peaches, and some varieties of apple, are also chilling sensitive. In this table, notice that some apple varieties are chilling sensitive, but the lowest safe storage temperature is 36 to 38 degrees Fahrenheit. If they were not chilling sensitive, then the lowest safe storage temperature would be closer to 32 degrees Fahrenheit. With asparagus, the lowest safe storage temperature can be between 32 and 36 degrees Fahrenheit. However, when we go to warm season chilling sensitive crops like cucumbers and eggplants, the lowest safe temperature of storage increases to 45 degrees Fahrenheit. The chilling threshold is defined as the lowest safe temperature of storage for a chilling sensitive commodity. In this table, we see that honeydew melon has a chilling threshold of 45 to 50 degrees Fahrenheit, and the exact temperature depends on variety and where it's grown. Bell peppers, or sweet peppers, have a chilling threshold of 45 degrees. Tomatoes, if they are picked mature green, that is, picked fully green and ready to ripen, have a chilling threshold of 55 degrees Fahrenheit, which is rather warm. However, when the tomatoes are allowed to fully ripen and then put into storage, the threshold is 45 to 50 degrees Fahrenheit, so ripening here has actually decreased the chilling threshold and made the tomatoes less susceptible to chilling injury. Some cut flowers are also chilling sensitive. Think of the tropical flowers anthurium, bird of paradise, camellia, ginger, and the subtropical plant poinsettia. Those that are not really very sensitive to cold are the more temperate flowers, roses, tulips, lilies, and chrysanthemums. Chilling injury is often referred to as cryptic damage. Cryptic means hidden, so think of cryptology, which is the study of secret codes and ciphers. Visible symptoms usually become more noticeable after the commodity has been transferred from a chilling to a warmer, non-chilling environment. So what are some of the symptoms of chilling injury? Surface lesions are often evident, and these can manifest as pin pitting or sheet pitting. Here is a photo of an eggplant that has been subjected to chilling temperatures, and you will notice the sheet pitting. Large areas of the surface tissues have died and collapsed, producing these brown sunken areas. Limes are very susceptible to chilling injury. Notice the sunken brown areas. This too is sheet pitting, and those sunken areas where the tissues have died have browned. Also with limes, when they're chilling injured, when you cut them in half and try to squeeze juice out of them, you will get very little juice being expressed. They dry out. Papaya shows extensive browning of its surface when it's chilling injured. On the left, we have bell peppers that have not been chilled. And on the right, we have bell peppers that have been chilled for 5 days at 34 degrees Fahrenheit and then warmed for 2 days at 72 degrees Fahrenheit. You can notice on the right the beginnings of pitting, which are small localized areas of cellular collapse, as well as decay spots. These bell peppers have been chilled at 34 degrees, 70% relative humidity. You can see the extensive pin pitting that has occurred on the fruit on the right. Snap or green beans are also chilling sensitive. These pods were stored for 2 days at 34 degrees Fahrenheit, 70% relative humidity, then warmed for 2 days at room temperature. The brown patches you can see is the chilling injury that has manifested on these pods. When chilling sensitive fruit are subjected to chilling temperatures, they may fail to ripen, or their ripening may be non-uniform. There may also be water soaking of chilling sensitive plant tissues. There may be textural changes, such as increased softening. There's often internal discoloration or browning of pulp, vascular strands, and if it's a fruit with seeds, browning around the seeds. This is an eggplant that has been subjected to chilling stress that has been cut in half, showing the extensive browning of the pulp of the fruit. Notice, too, the browning around the seeds. There can be a loss of growth or sprouting capacity, which is especially important with stored propagules. There can be reduced seed germination rates as well as reduced seedling vigor. Compositional changes can occur as the result of chilling stress, especially those that relate to flavor and taste. And very importantly, there can be an increased susceptibility to decay. Chilling stress is, to use a medical term, an insult to the plant tissues, and it weakens them fundamentally. If the tissues are weaker, they less effectively resist bacteria and fungi, and so rates of decay can increase dramatically. What's the effect on potential shelf life? For a non-chilling sensitive commodity, the longest shelf life is usually attained when the commodity is stored just above its freezing point. For a chilling sensitive commodity, the longest shelf life is usually attained when the commodity is stored at or just above its chilling threshold. Remember, the chilling threshold is the lowest safe storage temperature for a chilling sensitive commodity. Since the chilling threshold is warmer than the freezing point of a commodity, the chilling sensitive commodity's potential shelf life is significantly reduced. What are the practical effects of this? Well, the time to market a crop is reduced, the time to retail a crop is reduced, and a consumer's time to utilize a commodity is effectively less. Summary points. Temperatures above freezing, but below 59 degrees Fahrenheit, may cause damage to fruits, vegetables, and ornamentals, but the threshold of injury depends on the commodity. Crops of tropical or subtropical origin are most often chilling sensitive. However, some temperate crops are also chilling sensitive, but the chilling threshold temperatures are usually fairly low. Chilling sensitivity is a biophysical phenomenon where non-freezing cool temperatures are believed to gel discrete areas of cell membranes, resulting in metabolic dysfunction. Since chilling injury causes changes in plant cell membranes, it is not easy to fix through breeding. Common symptoms of chilling injury are external pitting and browning, increased rates of decay, internal browning, and tissue textural and flavor changes. A chilling-sensitive commodity must be stored at or above its chilling threshold, which decreases shelf life and reduces the time to store, market, retail, and consume the product.